All right, Randy, thanks for joining me here today. I got my cup of water and I'm ready to talk about robots.
Yeah, thanks for having me on.
Let's see, where to begin? How long have you been with Instructables?
Well, that's a good question. I've been with them over 11 years now. I've been there a while, since January 2007.
Wow, yeah. So you're an OG. You're like pre-Autodesk acquisition and all that, right?
Yeah, I was like employee number 6 or 7 or something like that.
And what brought you to Instructables? What was the road to get there?
So I had a friend who basically posted LED throwies, and he's like, "Hey, I posted my thing on this website, and it like blew up all over the internet. You should check out this site." So I started just sort of posting projects there, and during that time period, I moved to San Francisco, and I was unemployed, and I was looking for work, and then I realized they were also in San Francisco, so I just sort of sent in a resume. Um, I think my job to begin with was a little bit nebulous. They hired me because I was posting weird stuff to the site, but they didn't really know what to do with me. And I just sort of ended up in community management because no one else wanted to do it, basically.
And then how did you get started with you have so many amazing little quirky bots on Instructables. How did you get started building those?
So there's two things that really sort of inspired that. The first was I taught kind of a pre-college summer kind of camp program after I graduated from college. And at the time, it was mid-2000s. There was like a bunch of like robot type kits, and they were all kind of terrible. And I remember the summer was kind of like not so great for me. I don't know what the kids got out of it, who knows. But I remember thinking there has to be a better way, or to make something interesting and engaging than like working with these like very difficult to use kits. And while I was at Instructables, I had a coworker who was like, "I'd love to build robots, but it's too hard. I'll never know how to do this." And I was thinking, like, I bet I can make one in like 10 minutes. So I built one. I was never like a big robots guy, but I built one. I was like, "Wow, this is kind of fun." And I made another and another and another, and I just kept going. Yeah, it was just sort of an accidental type thing.
Well, I'm so glad it's led to this collection. I think this is one of those hidden gems of Instructables, is your repository of all these simple but like still ingenious robots. I don't want to flatter you to embarrassment, but I think it's a really great collection. Let me see if I can pull it up here. Do a little screen share, and here's just one of many. Let's see if I can lock this in. This is the skitter.
Yeah.
Right, and so I feel like the skitter I pulled up, it ties in a lot of elements of your different bots that I like. One of which is the Servo Hack, right? A lot of your bots, and I've hacked a servo for continuous rotation before, but I haven't hacked a servo like this where you take out the controller board. So it's basically like a geared DC motor that kind of locks position in one of two directions, right?
Yeah. So the reason I started doing that was because it was hard to find sort of a geared motor at the time that was easy to interface with. So I'm like, well, servos work. Its problem is you need the microcontroller. So what if I just rewire them for direct drive? And then, because they're a uniform size, a uniform voltage, uniform power, easy to attach to things. So they're super convenient. And also, like building things with this then makes you comfortable to then go on to like work with like actual microcontroller controlled servos. So yeah, it's just sort of led me to that. I've been thinking a lot actually, because there's a lot more options available these days of kind of what other ways can you sort of achieve the same thing without needing to basically remove all the value from the servo.
I don't know. I think the servos have that kind of mystery about them where you can't just, if you're not familiar with electronics and control signals and PWM, like a servo is just kind of this useless thing until you can connect it up to something that can actually send it a signal. And once you eliminate that aspect of it, and you can just plug a battery into it and get it going one way or the other, I think that really makes it an easier thing to wrap your head around as a beginner than what a servo is just on its own.
Yeah, I really wish someone would just sort of manufacture these so you don't have to modify it yourself. Adafruit makes like the micro size one like this, but I've yet to see anyone make like a standard servo. So if anyone out there is like listening, that'd be awesome.
And so you have a whole separate Instructable, and I have it in the description for this video, that's just on this particular kind of servo hack. I think you've got one that's on making a continuous rotation servo, and one on removing the controller from the servo so that it can just be powered. You just have positive and negative to make it go one direction. You can flip the voltage to make it go the other direction, right?
Yep.
And somehow I've not come across this Instructable until today, going through your different bot Instructables. And I think this is a really cool one for me to bookmark, because I have a lot of projects like where I want like a slow geared motor, but I don't want to order up some specialty geared motor. And this is a really cool hack. Of course, it involves one of my least favorite activities, which is desoldering things from a circuit board.
Yeah, it's a little bit throwing people in the deep end there with that part. But once you get the hang of that, then it's easy. I could do it now, probably the whole process in about 5 minutes, but I've been doing this a while.
Yeah. And so something like this, the Skitterbot, it's using that the controller board removed servo, and then it's actually using the brush, one of the brushes, to hit the switch, hit a physical switch back and forth to reverse the direction.
Yeah.
Right?
Yeah, really cool. Basically reversing its own motor direction over and over and over.
And just looking at this, and on all I love this part about all the robots. The bill of materials, it looks like it's 90% hardware store, and then just like that 1%, Radio Shack element to it, or whatever electronic store is near you element to it to get the servo and the battery pack. But you must have a lot of fun, and I can relate to you about this. Shopping at hardware stores. I love wandering around hardware stores. Do you spend a lot of time just looking through hardware store bins, figuring out what kind of robots you can make with different materials?
Yeah. So when I made the bulk of these, I was actually living in the Bay Area, and you might know these places. The two places that were my absolute favorite, and the employees got to know me, and they didn't understand what I was doing. They never really asked me, just so I was like this weird guy who come pick up everything. Colfax Hardware in downtown San Francisco, and Daiso. It was just like a Japanese dollar store.
Right.
Those were my two go-tos for like most of these parts.
Well, you can get stuff on the cheap for sure.
Yeah. Yeah, the idea was to be able to just get stuff, make it so that people can like understand what the parts are. Because like that was the problem with the robot kits. It had to use all these specialized parts, and then if you didn't assemble it perfectly, it wouldn't work. And I wanted to just use things like you could be like, oh, I have that in my house, or I know where to get that. Or like, I can't find that one, but I could find something similar and it'll still work. So that was sort of my thinking on that.
I also have to credit you for being the person who finally helped me understand the concept of an H-bridge. I feel like at this point in my life, I should have understood this better.
Yeah.
But somehow the diagram on this project finally made it hit home for me. So thank you for that.
Yeah. Amazing how bad some of the documentation is around this subject, because it's like kind of really simple.
Yeah, I feel like it's always like it's a motor. It sounds mysterious, and it sounds like every time I hear it, it's usually accompanying a picture of a controller board that has a lot of this built into it. But to see it as an idea of switches in a series, it made it so much easier to understand.
Yep.
And so you, on this particular project, you're doing an H-bridge on a double throw switch, right? That's the idea. You're actually wiring up a single switch to do the function of the switching the polarity back and forth.
Yeah. So basically, when the switch is flicked one way, the motor spins like clockwise, and if you reverse it, the motor spins counterclockwise. It's the simplest way you could kind of reverse the motor.
Yeah. And is that a common technique, and it's just new to me for not having tinkered with it, or how did you come across that?
So actually, the way I shouldn't say came up with the idea, where I stole the idea from. Yeah. At one point, Instructables had me build, because we would go to Maker Faire every year and we'd bring some of the projects from the site. So they had me build a useless machine. And I'm like, oh wow, the switch is reversing the motor direction.
Oh, right, yeah.
And I'm like, I'm sure I could do something with this. And I like sat on that for a while, and eventually it made its way into these robots.
Well, it's something I'm gonna keep in my back pocket for a while now. So thank you for that.
Yeah, it's a useless machine. That's the gift that keeps on giving.
Not so useless.
Yeah, not so useless.
Now, there's a lot of. Let me switch back over to the screen view. Now, I probably have too many of your robots pulled up here, but I think what's great is that, and I'll skip to this part over here. You have a lot of them collected, right? You have your Simple Bots collection over on Instructables, which came out. You grouped these together in 2010. It says. And you got Simple Machines, which is more of a current collection, maybe from your robotics class.
Yeah, this one was inspired by the robotics class.
And that's the other thing I should definitely point out to people is that you have the free robotics class on Instructables. Let's see, where is it over here? Robots class.
Yeah. So the class. Currently, it's just sort of a run through of the different parts you would use building robots, but it was initially project-based, and this telepresence robot I have over here, you can see it there. It's the one with the phone. That was one of the robots. There's still, if you go down the lesson, there's still links to these. It's not like incorporated as part of the class now, but yeah, if you go through this class, you can then build a series of these different robots.
That's great. And yeah, let's get to the servo, or it's not the servo, the telepresence robot. See, I've got it. I think I have it pulled up over here. Simple. I've got so many. Here we go. The building the telepresence robot. How did you come up with this idea? I love this one.
So this is sort of the first thing I built when I moved to the East Coast, and I sort of joked around with them. With my coworkers on Instructables, I'm working remotely. Like, I'm going to move to the East Coast and build a telepresence robot and mail it to you. So I'm still in the office, and I built it, and I never mailed it to them, but that's why I built it.
It's a practical way to actually do telepresence for Instructables.
Yeah, I had another coworker at the time who was also building a telepresence robot because he also went remote, and his was really complicated. He never finished it because it was like big and complicated and had a lot going on. And I'm like, I'm just gonna make out Tupperware and I'll be done.
Well, since you got it there behind you, can you pick it up and just kind of run through some of the features?
Yeah. So it has two wheels, kind of like center drive, so it could like rotate in place, go backwards and forwards. It has these switches on the front. They're not just like antenna, they're collision switches. So if it bumps into something, it backs off. It also has a distance sensor, so in theory it shouldn't bump into things, but they're not always 100% reliable. So redundancy is always useful. And there's a, I don't know if you see that. There's a little kind of like light sensor, which people normally use for like line follower robots, but I'm using it to sort of detect edges. So if it like gets to the edge of a table or like some sort of drop, like a staircase, it stops and doesn't drive over. And so all of those kind of run, but the way it's controlled, it's not really autonomous. It won't drive around on its own. I mean, you could program it to do that, but there's the phone. You open the Skype app, and in Skype, there's a keypad, a dial pad. And so this robot, if you can see here, has a little microphone. It's looking for DTMF tones, which are like telephone touch tones. And depending on which tone you press, will control the robot in different ways. It'll make it drive forward or backwards. And Also, you could tilt the phone up and down with this servo. So you could drive it around, you can kind of like look around. It's works actually really well. I've used it a few times, like actually really remotely. At one point, I was a little bit in a long distance relationship with my fiance. We were living like an hour or two apart for a brief period, and like I'd have her like drive around with the little robot. It was kind of fun.
And I like the tone. The tone is coming through the phone too. That's got to be a lovely element for the people who around the robot to hear the Skype tones come through as you're controlling it around.
Yeah, it's kind of annoying, but at the same time, it makes it actually really robust because you don't need to worry about there being like a cellular connection or like a Wi-Fi network. You just plug in any phone, it'll always work.
Yeah, and you've also it's a selfie stick that's extending it, right?
Oh yeah. It's just a selfie stick with some like weird plumbing parts zip tied to it. That's the other thing. I love zip ties. I think in terms of like simple little robots like this, they're like the most underutilized form of connector. They're super strong and they're cheap and they're quick. And if it like doesn't work, you just like cut it and try again. So yeah, this is largely zip tied together.
Zip ties and hot glue are pretty much the two patron saints of makers, right?
Yeah. Yeah, I'm not a big fan of glue. I'm like connectors, nuts and bolts, zip ties. Sometimes glue, but it's like once I forget who it was. I read a long time ago in Make Magazine. They're like, once you glue something, you can like not really ever undo it. I'm like, yeah, that's right. You can't. Like that's a good point.
So you've got the whole breakdown of the telepresence robot over on your Instructable here, or actually, it's a multi-part Instructable, right?
Yeah. So it's kind of grouped together in this collection of different Instructables, and the reason it's done that way is because it originally followed the class with sort of a certain progression towards building the robot.
Mm-hmm.
So in each part, well, first of all, to put in one Instructable would be massive. That'd be annoying, but I kind of go over the different types of sensors as you go through the lesson, so it is sort of still kind of educational. Like it sort of discusses like why this sensor is different from the last one you used, and like how you use it, and like what it's doing. So there's kind of a still learning element involved in this project.
It's great. Now this is probably, I wouldn't qualify this as a simple robot necessarily compared to the other ones, right?
Oh no, yeah. All of the simple bots, they all use just like a servo and batteries, and maybe they'll have a switch of some sort, but they're fairly basic.
Well, let's go back to some of my other simple bot favorites over here. The Squiggle bot. There's actually the Squiggle bot and its companion in concept, the Scrub bot. But let's start with the Squiggle bot. This is I mean, I've seen a lot of art bots like this before, but this is one of the most, I think, elegantly thought of that I've seen before, where you're really just hacking the PC fan to be everything, right?
Yeah. This one came about, I wrote a book called 62 Projects to Make with a Dead Computer, available on Amazon and fine booksellers. And when I was doing that, I basically...
Sorry.
Well, that's fine. I literally went on to Craigslist and FreeCycle and said, hey, do you have any broken electronics? I'm like writing this book. I'll take them off your hands. And I got a much larger response than I ever thought I'd get. So I had a room full of broken electronics for a while, like floor to ceiling. And so I was just taking things apart and like sort of like looking at the different parts. And I realized if I like broke off half the fan blades, I'd have this really nice vibrating motor. And I'd like seen some drawing bots before, and like I bet I could just like attach a few. This whole was just happened back. So I'm like, what if I just attach a few markers to each post or bolt, hole, whatever you call this? And it worked really well. It was sort of like a surprise, incidental type of thing.
Yeah. Yeah, I love the idea of creating the imbalance just by clipping off a few of the fan blades.
Yeah, that worked out better than I thought it would. Yeah, it's really easy to make vibrating motors.
And then, so yeah, and you use the same concept, dual fan vibrating, what is this called, like an eccentric motion motor on this scrub bot.
Yeah.
This is another Daiso free for all here with the scrub brushes and the frisbee.
Yeah, actually, I'm not sure this one was done. I think this one was Colfax.
Ah,
All
yeah.
of these came from Colfax. Even the frisbee, yeah, this was entirely hardware store. And yeah, I was just started, and that's sort of what's great about zip ties. I just started zip tying things together, and I had like the motors together, and I'm like, okay, now what can I attach it to? Okay, I'll put it on this frisbee. I'm like, now what? And I found some brushes. This was more a chance encounter one. Some of them I like design and think out and like sketch out and like have like a very clear plan in mind, and this one was just sort of came together.
Hey, I think it's a great idea. And then are these like window latch? The brass parts, or like, I'm trying to think of where I've seen that before. Maybe for like popping a window out.
For doors, not for doors. It can't be. They're for windows. It's just like if you have like, I remember in like elementary school you had those where the window could only open so much.
Yeah. It's great. And so, and then the two motors back to back create a like just more force. Is that the idea?
Yeah. I was trying to create a little bit of like chaotic motion, but I didn't really do that. They ended up just spinning in the circle, sort of. It just sort of gave it a little bit more.
It's great. I'm excited to try this one. I've got some PC fans hanging out in my workshop here that I got from a kind of a maker shed going out of business sale years ago that have just been waiting for a project. There's only so many solder fume extractors you can make with those.
Yeah, that makes sense.
All right, and then let's move on to solar power as another option. This is getting a little bit more advanced, maybe. But you also introduced another idea that I knew must be possible, but I hadn't seen expressed until I read this Instructable on your solar-powered version of your servo bot. But the idea of doing the diodes that would allow both the charging of the batteries or the moving of the servos depending on how much voltage was coming from the solar panel. How'd you come across this idea?
That one I found just in research. I think, where did I see that? Probably.
Actually, you had a link over here to.
Right, here.
Yeah. Yeah.
Yeah. I was researching kind of, what are those called? Little solar robots.
The beam, like the solar bot?
Yeah. Beam robots. And I just stumbled upon this page.
Yeah, I've been trying to do more solar projects, but I always seem to need to buy some relatively expensive charging board that can handle, both charging the batteries and providing power to the project. This seems like a much simpler way to do it, at least with a fairly simple project.
Yeah, I don't know how reliable it is. I'm not really sure like how much loss or like if at some point the batteries will discharge more than they can recharge.
Mm-hmm.
But it seems to be working thus far. It's been years now.
I also love this idea of, I love the materials list on this particular one where you've got both the aluminum ruler and the adhesive coat hanger hooks.
Yeah.
As the legs.
Yeah. It's the same as I use for this little wobble thing. I basically, at some point, just realized if you use shapes other than circles as wheels, you get interesting results. So, yeah, if like it's not always making constant contact with the ground, you can get like a walking type motion. Or if you have a couple of them attached to one motor, you might get like some sort of weird stumbling type of effect.
And then since you have the wobble bot behind you there, do you want to talk about that one? Is that the latest one?
This is one of the first ones I've built. I have a few of these. Unfortunately, most of my robots are in storage because I'm in a tiny New York apartment. But I have a couple I keep around my apartment for rainy days or whatever. And so this one just sort of like walks around. What's fun about it is just sort of how simple it is. Because I always tell people all you need is just some batteries and some motors and like some random parts, and you can have like a convincing robot. And this one, like, I feel like everything I make demonstrates that, because it's basically Tupperware with like 2 code hooks and some motors, and it seems like it's like alive or like intentional or doing something, even though it's really kind of like one of the simplest like electromechanical machines you could imagine.
Yeah, and that for me that goes back to the Beam Robotics stuff too. The couple of those projects I've taken on where you're just kind of doing point-to-point soldering on little motors and solar panels. Just a few elements can really make something seem like it's got a life of its own.
Yeah, that's sort of what really intrigued me after I made the first robot. Like, I really didn't do much of anything. Like, how far can I push this? It's like, usually, because when people build robots, they have some sort of intention, or they're like trying to accomplish a task. But mine was just to sort of like make something that seemed like that passed as a robot. So once that was like just sort of open the gates to like, okay, what can I do?
And getting back to the kind of the origin story of your quest for making these better bots is I remember you talked about how you were teaching a unpleasant summer camp on robotics kits, and it just didn't seem like a lot of fun for all the educators out there or people who are doing projects trying to do more STEM robotics projects, because I feel like there's more and more of those now that I see, which I think is great. But where do you think they go wrong at all? Like what about the robotics kits that you remember wasn't such a fun experience, and what do you think educators could pull from some of your projects that might make the projects you're doing a little more engaging?
So what I thought, well, logistically, the first problem we had was the kits were reused every summer, so some of them were just missing parts. And so like they would build the robot halfway, and then just part would be missing, and be like, now what? What are we gonna do now? So that was like sort of the first problem. But that aside, the ones we did finish, it was just sort of like you built it, and you spent all this time, and it's like sort of like, I love Legos, but like if you like get the Legos and you follow the directions, you have the thing, and you're like, okay, I've made the thing, and then it's like I'm done with the thing. Now what? And so I feel like it's hard sometimes to rationalize, like, okay, I can like experiment, I could play with this, I could like change it. And the kits didn't really allow for that. And so that's sort of why with the simple bots, one of the nice things is like everyone builds it differently. There's like, it's not as clear cut. It's like people might attach it slightly differently and they'll get different results. Or they could like be like, oh, I don't like that, I'm gonna attach the motor over here. So it allows for like a degree of like playfulness and creativity, and you get immediate results as soon as you connect the batteries, it starts moving, as opposed to like I have to worry about whether or not the linkages are connected correctly, like, or I have to program this thing. I purposely removed all programming from the process.
Yeah, no, and I think that's cool, because I remember being at that state pre-Arduino and with the intimidation of programming, and being able to know that I can get a project done if I could just put some wires together was, really powerful. So I think that's a cool thing to keep an eye out for.
Yeah, that's the other thing. This, when I did the class, which maybe like influenced, I think it was pre-Arduino. And, like, Arduino changed everything, and like, which really sort of is amazing and frustrating because like I see things made by like 8-year-olds now that like I struggled to make in college. And it's like, to make that, I had to get like the special development board and like have to bootload the chip and like do all these things just to like make an LED blink. And then like there was no information online, and you had to like find the one guy somewhere who knew what he was doing. And everyone was like reinventing the wheel over and over and over again. So like Arduino, it's not like, honestly, it's not the best technology out there, but it's like the easiest to use, and it's like the most widely used. So it's, I think that's the beauty of it. There's just a community. That's really where I think it's interesting.
Yeah, you can find, if the one sketch doesn't work for you, you can find a handful of others that might do the job, right?
Yeah. Yeah, because I've been teaching sort of a couple different college classes. So my students get frustrated with me because they're like, I don't know how to do this. I can't do this. My code's not working. I'm like, well, just Google for like whatever your problem is, Arduino code, you'll find it. They're like, but I want to learn to do it. I'm like, well, that's how you learn.
That's the biggest part of the learning process, is learning how to search for the solution or someone else's solution to your problem, right?
Yeah.
It works for me. Yeah. The other thing I wanted to mention, we were talking about the payoff of the kind of early robotics experiments for kids. And I'm not a kid, but I do know, like, from my early experiences playing around with little simple DIY robots, I really loved the art bots and the squiggle bots and things like that, that when you're done with it, even if it came out kind of crappy, you still would have the payoff of watching it crappily make some weird art on the floor. And it was more about what it made, it was more about making the mess than it was about the robot. Has that been your experience too, or?
Yeah, I love the art bots. Every once in a while I think about making more and I don't, but it's something that's always on the back of my mind. I've recently started making, I've been playing around more these days with optics. I've been making things do weird things with like cameras and motors and like mechanisms. For instance, well, excuse me. So I made this kaleidoscope. I'll hold up to the camera.
Yeah. Ooh. Yeah.
So I made a mechanism that like automatically spins it. And like you could film through it, and that's kind of was fun to me. And I'm like sort of seeing like, well, what else can I do with like weird lenses and motors and things like that? So that's sort of like art bots, but it's like a little bit more complicated. But a long time ago, I made things with basically during computer book phase when I had a lot of fan motors. I basically just attached a motor to the ceiling by a string, and another string down to the floor with a marker, and I had a bunch of them just moving at once. And they would like bump into each other, and they're making these really weird drawings. I like think about that a lot sometimes. I'm like, I should revisit that sometime, but you have to do that.
I also know you've got a lot of guitar pedal projects up on Instructables too. Can you tell me a little about your introduction to getting started with guitar pedals and where that's taken you?
So I've been playing guitar really badly for a very long time. And at some point I decided to build a fuzz pedal because I just didn't own one. And so I built one that wasn't so hard. I'm like, okay. That's sort of actually how I started really learn, like really learn electronics. I mean, I learned it, I went to art school, so I like learned a little bit in college as like physical computing. Mm-hmm. But I didn't like really go too deep into things. But once I started building the guitar pedals, I started to really learn like what different types of transistors did and integrated circuits and all of that. And so it was just interesting to me because you got a result. You got like the same reason the art bots. You like no matter what you did, you got some sort of result, like musical result at the end.
Yeah.
And like I was learning a new skill while doing it, and it was also much cheaper than buying pedals. And then at some point I realized I'm just more interested in building the guitar pedals than playing guitar. Yeah, I don't know what to do with them. I have a lot of them.
Yeah, I feel like the modular synth community can be like that too, where there's a lot of guys who are and girls who are into building the modules and connecting them all up. But at the end of the day, they're not necessarily looking to record music with them, or just kind of plug them all in and let them run and see what they can do.
Yeah, it's really easy to get lost in that world. I made them a few years ago. I was trying to build a synthesizer, and a friend walked over, and he like kind of made the snarky comment, like, "You made the world's like most complicated children's toy." It was kind of funny, so I put it into a big box and gave it to my niece and nephew, like big buttons.
Uh-huh.
And I never actually finished the synth I was building for myself. But yeah, it's easy to like build this thing and never actually do anything with it. What I'd love to do is like find someone who can really play guitar to like use my pedals. Like, I know every time I have to sort of make a demo video showing off what I've made. And I've gotten like progressively worse at guitar over the years. I dread having to make those videos.
All right, now you've got another amazing looking robot behind you that with the treads on it that I need to know more about. Can you tell me about that guy?
Yeah, so I made it for so there was an editor at Popular Mechanics a few years ago who was writing an article about automated lawn, and he found like a lawnmower and like watering system and a few other things. I forget what they were. And the one thing he couldn't find, which he wanted for his lawn, was a seed spreading robot. And so we sort of like encountered each other through Instructables. And he asked me, like, "I see you've been building all these robots. Could you build a seed spreading robot?" I'm like, "I guess I can, but it's not going to work very well." He's like, "That's perfect. That's fine." Because that's like a really complicated task to like build one that actually like really works well in a big wide open space. So I made this, and he used it on his lawn, and it was a disaster. Like, it was supposed to make stripes back and forth, but it just sort of like made this big mess of a pattern. I always want to like follow up and find out what his lawn looked like now.
Just says Randy on his lawn.
Yeah, I could turn it on. I thought it. So, like, full disclosure, I thought it's been broken for years, but I like poked that a little bit this morning, like got it running. Like, it's sort of running. It'll turn on.
The part of the show where Randy gets his arm torn off by his seed robot.
Basically, yeah. Yeah. So let's turn it off. Yeah.
That made the video, Randy. I'm probably just going to cut all of this down to just that part where the robot starts terrifying us and attacking you.
Yeah, that was when it has seed in it, it's like really going. It's like a sight to behold. Yeah.
All right. Well, what else do you think people? What else would you recommend to people who are getting started with simple robotics? Just to get back on the simple robotics topic and put a bow on it. What do you think? What do you think people get hung up on, and what do you think people? What advice would you give people who want to get started?
So yeah, there's a few things people get hung up on. They get hung up on making things perfect before they even built the thing. They're like have this very big vision in mind and like never even start because they just like don't know how to get from point A to point B. Also, code. I think coding is a problem. I think basically just make it work. Just make it work and see what it does, and then you can worry about whether or not like it connects to Wi-Fi or it like does all these like fancy things that you want it to do. Actually, brought this out today. It's kind of dumb, but like when I build robots, like this is an example. It's like just like a just random stuff I had around, because I sort of had this idea. I'm like, well, what would this happen? But it's like this weird, like twitchy type thing.
The Twitcher stick. Yeah.
Kind of. Well, the aluminum stick is just sort of incidental. This part was the part I was interested in.
Yeah.
And basically it's like just a bunch of scrap I had around. So I'd like to think about things like, rather than like, how do I make the part? Because like that's the thing people get hung up on. Like, how do I make this part? How do I make the frame? Just like find something that looks. That's what the simple bots are, like the beautiful parts. Like just go to the store and find something in the general shape you want, and then like attach it together. And even if you don't want at the end of the day like some weird selfie stick robot, at least you like have the prototype. You can like make prototypes really quickly, and that's one of the things that my students get hung up on this all the time. It's the idea of making a prototype. It's like no one wants to do extra work, and they think that the prototype is extra work, but that's like the most important part. It's like build it once and see if it works before you like commit fully to building this thing which doesn't work at all.
Right, or seeing where the prototype fails, that will save you the time of making a perfect version of the thing that fails, so that you can make the version 2 that actually corrects the problem, right?
Yeah, basically. And I don't want to get into like a whole bunch of like kind of tech industry kind of like sayings like fail quickly, try again type stuff. But like basically that, yeah. Like,
yeah.
Like prototype a lot, like try it right away, see if it works. Like, because it doesn't really matter what the code is if like the basic fundamental movement doesn't work. And like you won't know that till you actually try that. So like whatever the fastest way to get there, just do it and keep going. And so it's just because there's a lot of different elements of building robots, so it's easy to get bogged down in one. Like, oh, I need to figure out the code, or like I need to get the sensors working, or like how am I going to build this? And it's sort of like at the end of the day, you have to worry more about the interaction. Like, how is the thing working as like a whole? Like, and one example. In one of the classes I was teaching, they were building basically a phone charger which ate your phone, which was kind of funny. And they were like worrying about like how the door would work and how the charger would work and where the cable would go. And I'm like, have you tried like, and I was gonna like live in the school and attend a computer lab. I'm like, well, have you tried simply putting a box in the computer lab with a wire and see if anyone plugs their phone in? Like, no, I'm like, you might build this thing and no one will use it. It's just like, it's the simplest things you have to like kind of consider when building kind of like any mechanical type thing.
That's great. And then is there anything you feel like you want to direct people to, or where can people find out more about you?
More about me. So if you go to instructables.com/Randy, you can find all of my projects and my various I have a robots class, an electronics class. I have a class for controlling really large motors. You can also go to randysarafan.com. It's just a broader collection of things I've made. A few things I don't have on Instructables. That's about it, really. Follow me on Instagram. I love getting Instagram followers.
Is it your Randolfo on Instagram too, or is that it?
I think it's Randy_Sarafan.
Okay.
Yeah,
cool. I'll get that in the description too, and you can find out all the projects we talked about today in the description here for the video. Hopefully that'll live here, including links to I'll get Randy's Instagram and Twitter and all that stuff in there. Yeah, if you're still watching and you haven't subscribed to the channel, you should subscribe to my channel. And thanks, Randy, for joining me in this talk. And we'll hang out a little bit here too, to see if there's any questions people want to ask you. Okay.